Hello YouTube family, let's solve this nice algebra problem, which is a squared subtract a cubed. This is equal to 12. So what is the value of a? Now solution from here, solution from what we have, which is a squared subtract a cubed. This is equal to 12. Okay. Now from what we have here, find that we can take this 12 on the left hand side. We'll have a squared subtract a cubed subtract 12. This is equal to 0. Okay. Now again, from what we have here, we can express 12 as 8 plus 4. Okay, it's the same thing as 12. So 8 plus 4 is the same thing as 12. Okay. Now again, from what we have, we can say this is a squared subtract a cubed subtract. Now we can express 8 as 2 raised to power 3 as 2 raised to power 3. Now negative times positive, this becomes a negative 4, whereby you can express 4 as 2 raised to power 2. So this is subtract 2 raised to power 2. This is equal to 0. Okay. Now we can combine the s. We can combine a squared subtract 2 squared. You can see they have the same exponent. Subtract a cubed subtract 2 cubed. This is equal to 0. Okay. So from what we have, we can combine a squared, that is a squared subtract 2 squared. Okay, they have the same exponent. Subtract a cubed subtract 2 cubed. This is equal to 0. Okay, now we have a squared minus 2 squared subtract. Now this is the same thing as a cubed plus 2 cubed. Okay, this is equal to 0. Now from what we have here, a squared minus 2 squared, this is actually the difference of two squares expressed as x squared minus y squared, which you can express as x plus y and x minus y. Okay, now from what we have here, we have a squared subtract 2 squared. This is the same thing as a plus 2 a minus 2. Okay, now from what we have again, the second part is actually a cubed plus 2 cubed, which is actually in the form of a plus 2 a squared minus 2a plus 4. Okay, so now we can combine the first part, which is actually a plus 2, which is a plus 2 a minus 2. Okay, subtract, we have a plus 2 a squared subtract 2a plus 4. This is equal to 0. Okay, now from what we have here, from the equation we have, a plus 2 is common, so we can factor out a plus 2. Let's factor out a plus 2, so that we'll have a subtract 2 subtract. Now we have here, we have a squared subtract 2a plus 4. Okay, this is equal to 0. Okay, now from what we have here again, a plus 2, we can comfortably, we have two parts here. We have a plus 2, and into the parentheses we have a minus 2 subtract a squared minus 2a plus 4. Now the first part, a plus 2, this we can equate to 0, whereby a1 is equal to negative 2. Okay, so this is a real root, this is a real root, this is a real root. Okay, now let's check what is in the parentheses. We have a subtract 2 subtract a squared. Okay, now negative times negative, this is plus 2a minus 4. This is equal to 0. Now we can write this as a squared. Okay, a squared. Now we have a plus 2a. Now this is actually 3a. Okay, now then negative 2 minus 4, which is actually, this is negative 6. This is equal to 0. And remember, this is negative a. This is negative a squared. So we can multiply both sides by negative 1. Okay, let's multiply both sides by negative 1, so that we'll have a squared subtract 3a plus 6, this is equal to 0, okay? So we have a squared minus 3a plus 6, which is a quadratic equation, with a equal to 1, b equal to negative 3, and c equal to 6, okay? Now from what we have here, we can check the discriminant value so that we can check the nature of the root. Discriminant value is equal to b squared minus 4ac, okay? Now b squared, that is negative 3 squared, subtract 4 times 1 times 6, okay? So from what we have, this is 9, subtract 4 times 6, which is 24, and this is equal to negative 15, which is less than 0. So in this case, we have two complex roots, okay? These are two complex roots, and these are imaginary roots. Okay? Now from what we have, applying the quadratic formula, we're going to have a is equal to negative b plus or minus the square root of b squared minus 4ac, divide everything by 2a, okay? Now let's substitute the values of a, b, and c so that we'll have negative times negative 3, okay? So that is 3 plus or minus the square root of b squared minus 4ac, okay? B squared minus 4ac is the same thing as 9 subtract 24 divided by 2 times 1, which is 2. Now, we'll have 3 plus or minus the square root of negative 15 divided by 2, okay? Now, from what we have here, this is 3 plus or minus. Now, this is the same thing as 15 times negative 1 divided by 2, which you can express as 3 plus or minus. Now, the square root of negative 1, this is I, okay? We'll have the square root of 15 multiplied by I, everything divided by 2, okay? So that means that we have two complex roots here. We have two complex roots. And therefore, so that means from what we have here, we have two complex roots. That is, a2 is equal to 3 plus square root of 15i divided by 2, and a3 is equal to 3 subtract square root of 15i divided by 2, okay? Now these are two complex roots, okay? And now we have only one least solution, which is a1 is equal to negative 2, okay? Now from what we have, if you recall, we can check if a1 satisfies the equation, okay? So remember, we end that a squared subtract a cubed, this is supposed to give us a value of 12. Now let's substitute the value of a. So this is negative 2 squared subtract negative 2 cubed, this is supposed to give us a value of 12. Now negative 2 squared is the same thing as negative 2 times negative 2, which is negative and negative actually simplify. This is 2 times 2, which is equal to 4. Okay, now we have 4. Subtract, this is negative 2 cubed, which is the same thing as negative 2 times negative 2 times negative 2. So this is the same thing as negative 8. Okay, so we'll have 4 subtract negative 8. This is supposed to give us a value of 12. Now, this is negative times negative, which is actually positive. So this is 4 plus 8, which is 12, and this is equal to 12. And that verifies the equation. That shows that the value of a, which is the negative 2, satisfies the equation. So thank you for watching. Follow the steps and kindly subscribe. Thank you.